So substitution is a concept that definitely gets used again and again and again, just like that wonderful factoring that we'll review later on. So what is substitution? Since I said it gets used frequently, what is it?
It's where you solve for one of the variables and then you plug, like, so if you get y equals x plus 1, you plug in x plus 1 for y in the other equation.
Yeah. So he said solve for one of the variables. So we're solving for one variable. And then substitute. What's another word for substitute that we could use? He said plug in. What else do we use for substitute? Beginning with an R. Replace. Yeah. So we will be replacing that expression, whatever y or x is equal to, into our second equation. And the key thing is to make sure that you're replacing it in the other equation. So you can't solve for y and then go back into the same equation. It doesn't work that way. You gotta use both. If you replace it back into the same equation, you end up getting like 0 equals 0 because everything cancels out. So you solve for one variable, you take that expression that you get, whatever it's equal to, and you plug that in the second equation. So the goal is to have one variable left so that you can solve. So we usually think about replacing. You're substituting, you're replacing something. So there are a couple of steps here, which is kind of what Nick was talking about. So blank one of the equations for one of its variables. Sometimes this step is already done for you. Solve one of the equations for one of its variables. And it doesn't always have to be y. Sometimes it's easier to solve for x. Substitute the expression from step 1 into the other equation, and then solve for the other variable. So you're taking an expression, you're plugging it in, and then solving for the other variable. So solve for the other variable in your equation, which is kind of repeated from step 2. And then step 4, substitute the value from step 3 into the revised equation that you had in step 1 and so kind of it's just really, I'd say a 2, maybe a 3-step process. You get one equation by itself, you take that, you plug it in, you solve, and then you have to take that new answer and plug it back in because we need to know what x and y are. So once you have one of the variables, you still have to find the other. So I believe there are 2 examples underneath. Yeah. So looking at the 2 examples with substitution, how do you know which variable is good to solve for? Because you have 2 options for x, 2 options for y. Jack, how do you know which one would be a good choice to solve for?
The first one has x almost right, so.
Yeah. So if you have a variable that has a coefficient of 1 or negative 1, that variable is pretty easy to solve for. If you solve for a variable that has a coefficient in front of it and you have to divide and get fractions, then you probably should pick a different variable. You don't want to get fractions in your problem if you don't have to. So when you look at the 4 options, 2x versus 2y, pick the variable that has a coefficient of 1 or negative 1 in front of it. So Jack, if I solve for x, x would be equal to?
Negative 2y minus 2.
Right, negative 2y minus 2. So then substitution says you take this expression and you go into the next equation. So instead of x, we're replacing it with this quantity, or this expression, negative 2y plus 2. So that's where substitution comes in. So we have a 3. It says x. X is now negative 2y plus 2. So I still have an x, but we replaced it with whatever it was equal to. And then negative 2 things, minus 2. And then the rest of it stays the same. So I still have to continue writing the rest of the equation. The plus 4y, the equals 6. The only thing that we replaced was the x. when you look across that equation, you should have all y's or all x's. You can't really solve an equation for two variables, so this is a way around getting rid of one of those variables. So distribute, combine like terms, get the y by itself. So Peter, if we combine the y's and take the 6 to the other side, you end up getting? So y is -6. So now we have y. What else do you have to do after you get y? Chris? Yeah, go back and solve for x. Remember, your answer is an ordered pair. The two values together represent a point where the graph crosses, the two lines cross or intersect. So solving for x, taking that -6 and plugging it back in. So make sure when you write your answer, you're combining them together as an ordered pair. Don't leave it as x equals and y equals. They're not two separate values, they're one point connected together. So your answer, combine those two together. So you should have, so looking at part B, I'll be right there. I need to get this back up. So we get 10 and -6. At the very first step over here?
Yeah.
Because we're trying to get this to the other side to get x by itself. So we have to subtract it to the other side. Yep. Other questions?
Can you just solve both equations for one variable and then replace one equation with the other?
You could do that, yes, but ultimately that's a lot more work. And in this case, if you solve the second equation for that same variable, you're going to get fractions in the equation. Because you're going to end up with like a 4/3 value in front of y. So yes, I mean you can get both equations equal to the same variable and then set them equal to each other. But that is definitely more work doing it that way. Other questions? Less work is better. At least that's what you usually think. Less work is better. The second one, we have 3x minus y equals 5. So again, solving for the variable that has a coefficient of positive or negative 1 in front of it. Cole, if you solve that second equation, what do you end up getting?
X equals 3 or
So if you solve for the equation with the y in it.
y equals 3x.
Yeah, y equals 3x minus 5. Again, solve for the problem where you won't get a fraction. If you end up having a fraction in your equation, then you gotta work with fractions. So look at the variable that has a coefficient of 1 or -1, and that's the y. So looking at the second equation, this is now replacing y. So 4x, 2, and then y is now 3x minus 5. So the part that replaced y was the equation that we just solved for. Y is equal to 3x minus 5. So JT, when you distribute, you get
4x plus 6x minus 10.
and then combining your like terms and getting the number to the other side, we would have,
10x equals
so x is 2. So here's x. You'll plug that in to get y. So coming back up here to that equation that already is in y form, JT, 3 times 2 minus 5 gives us a y value of, so your ordered pair is 2 and 1. So yes, there are 4 different ways you could really do the problem. Because you could solve for any of those 4 options. You could solve for the x in the first equation, the x in the second, the y in the first, the y in the second. But if you end up getting fractions, it's just a little messier to work through. Yes, it works, but you have to kind of work through the problem with fractions. Questions? So those are your 2 review examples of substitution. You get 2 of them. Because we're going to do, I think, a couple on the next page dealing with elimination. So substitution, you get one variable by itself, you replace it into the next equation. So if you flip the page, we got elimination at the top of the next page. How would you explain elimination? Chris, what happens with elimination?
So you either choose X or Y, you want to cancel out, and say you got 2X and 4X, so you multiply the whole equation with the 2X in it by 2 in order to get 4, so they cancel out.
Yeah. So he said our goal is to get something to cancel out. And the way that happens is by having the same coefficient with opposite signs. In front of one variable. So this is like the cancel method. I want a variable to cancel. So substitute, replace, eliminate, cancel. So substitute, I replace something, eliminate, we're literally canceling a variable from the problem because they have the same coefficient with opposite signs in front of it. So the elimination method requires some multiplication. We have to kind of tweak the equation a little bit to get the coefficients to be the same. So it says multiply one or both equations by a constant. A constant is just a number. So maybe we have to multiply it by 5, maybe I multiply it by 2, maybe -3. Or maybe both of them need to be multiplied by something. To obtain coefficients that differ only in sign. That means one has to be a plus and one has to be a minus. That's what differing by sign means. So I have to have one with a plus, one with a minus. Adding the revised equations from step 1, so we have these 2 new equations, we are going to add them together. By combining the like terms, we will eliminate, cancel one of the variables, whichever word you want to use there. It's not a very big space. And then you'll solve for the remaining variable. Once you eliminate, it's a really easy piece to solve. And then of course you're going to substitute that answer that we had in step 2 to solve for the other variable. So we always need 2 answers here. We need an x and a y because it's an ordered pair where the lines are crossing. So elimination requires multiplying by a constant to have the same number in front, one with a plus, one with a minus. We add them vertically, combining like terms, and solve for the leftover variable. So here's our elimination method. We have 2x plus 5y equals 14. 4x plus 2y equals -4. So how would we use elimination, Jack? What do you think? Yeah, so the top equation, he said multiply by -2. So here's a 2x, underneath is a 4x. I can make the x's the same with different signs by multiplying the top equation by -2. Now remember, you need to multiply everything in that equation by -2 to keep it equivalent. So the new equation is -4x, -10y, and -28. And then you are adding vertically. So you're multiplying by 2, -2. And then you're adding that new equation vertically with the one that currently is sitting in the problem. So Jack, when you add those together, what do you get?
-8y equals
32. And divide by -8, so y is 4. So after you find y, go back into one of the original problems. Don't use the new problem that you multiplied by. So either one of the original problems and plug that value in. So I usually use the first one, but if you want to use the one that has the smaller numbers in it, totally up to you. But you need to take the answer and plug it back in because we have to find the other variable. So you take the answer that you have, plug it back into either equation. So Nick, what'd you end up getting?
X is -3.
Yeah. How do you rate your answer, Nick?
-3, 4.
So x was -3, y is 4. So see if you can solve letter B, trying to decide what to multiply by. So sometimes you have to multiply both equations, sometimes only one, depending what you see. So adding vertically. So because this equation will change, we're not using that, so we're using the current equation. Anybody else have questions that I can come around and answer? Sometimes you have to multiply both equations to get true equations to work with. So like what if I multiply that by so they become the same Or what if I multiply these by so they become the same No, because both of them have two. You're going to multiply by something, so I'm going to multiply by yeah, you guys can do C too if you'd like. We're going to jump a couple of problems then and go to the back page. How many of you multiplied to get rid of the x's? So about half, and the other half of you multiplied to get rid of the y's. So if we get rid of the x's, what would we multiply the top equation by, Alyssa? What would you multiply the top equation by? 5, and the bottom equation by? 7. So our goal is to make them the same number. So if I multiply the top one by 5, we get a 35 in front of x. A 60 with y. And then Alyssa, negative 22 times 5 is? Negative 110. The bottom equation, we now have negative 35x, so my x's are the same, 56y, and Alyssa, 98. And Alyssa, when you combine them together, by adding vertically, the x's cancel.
4y is
Sorry, I missed my 6. Negative 4y equals negative 12. So y is 3. So the goal is to multiply by something so that the variable has the same coefficient. If you use the y's, I think you all had 24 for the y. So you would multiply the top one by 2, the bottom one by 3, and you end up getting x first. So Jack, what did you get for x?
2.
So Jack got 2 for x, and add 36. We also get 2 for x doing it this way as well. So we have the ordered pair 2, 3. So either way, you should still get the same answer because they're only going to cross at one point. No matter whether I solve for x first or I solve for y first. Questions? So if you solved letter C, you should have gotten negative 4/3 and negative 2. I'm going to jump to the next page and do a couple examples on that next page because I do want to do a word problem together. So if you got letter C done, negative 4/3 and negative 2 would be letter C. So if you look at the next page, it says independent practice. I'd like to go down to number 3, A and B. This one says that you can solve using either method, and there's a group of problems, 29 to 39 from your homework, that asks you to solve using either method. My only requirement is that you have to try to use both methods for various problems. So don't use elimination for all of them. Try and use substitution as well. So you're not doing both ways for each problem, but there are 6 problems there. So at least do 2 of the problems using substitution. Don't just use elimination for all of the problems. Because sometimes substitution really is a better way. It might be a little quicker because you have that one variable by itself. So if you look at number 3, A, we have 2x minus y equals 8. And then we have 4x minus 2y equals 8. So again, I'm going to try and use both methods here. We just did a couple with elimination. So I would say let's try substitution because this has a coefficient of a negative 1 in front. So my equation would become y equals 2x and then minus 4. So taking the y to the other side, getting y by itself, it has a negative in front of it. That would make 2x minus 4. And then substitution says take that and plug it in. So again, your homework, each problem doesn't have to be done both ways. But I want you to use those 2 methods for those 6 problems. Jack, question?
That the minus
Why?
is the same line.
Okay, but you still have to show why it's the same line using one of the 2 methods.
So I was going to say if you divide the second one by 2, then you have the same equation.
So again, you got to show, I want to see either of the 2 methods, why is it the same line without like algebraically saying. So that's like graphically thinking.
Yeah, then it would be 8 equals 8.
Yes, so then if I solve this, these guys cancel and you get 8 equals 8. So algebraically, if you end up with an answer like this, that's when it is infinitely many solutions. Yes, graphically it's the same line, but what does that look like algebraically using substitution or elimination? So infinitely many solutions, when you end up with an equation that has a statement of 8 equals 8, or 7 equals 7, or 0 equals 0, that's infinitely many solutions. If you end up with a statement that says 8 equals 9, that's not a true statement. Then there would be no solutions. So 8 equals 8 is a true statement, infinitely many solutions. Letter B, what could we multiply by with letter B? Nick?
You can multiply the top by 3 and the bottom by
So he's getting rid of the y's here. So multiply the top one by 3, the bottom one by -2. And Nick, when you add them together, you end up getting,
X equals 4.
yeah. And then plugging that back into one of the two original equations. We would subtract that 12. And Nick, the y value is 5. So 4, 5. So you got to see one of each there. So a substitution where the answer actually was infinitely many, and the elimination where we get an answer of 4, 5. So I have 3 minutes, and I do want to talk about that word problem down below. See if we can at least write the equation. So write a linear system and then solve. To raise money for a new football uniform, your school decides to sell t-shirts, silkscreen t-shirts. Short sleeve t-shirts cost the school $5 and are sold for $8. Long sleeve t-shirts cost $7 and are sold for $12. The school spends a total of $2,500 but sells them for $4,200. It's a lot of information. Try and group the same type of information together in one equation. So think about what are your costs versus how much money would you be earning because you're selling them for a certain amount. So we need a cost equation. What are the costs? Ava, what are the costs? So we spend a total of $2,500. And how would I get that cost? So X would be t-shirts. Y would be the long sleeve. So the cost for my short sleeve and the cost for the long sleeve. Total cost $2,500. How about a second equation? What money are we bringing in, Chris?
8x plus 12y.
And how much do we earn total?
4,200.
$4,200. Make sure you define the variables that you're using so we know what X and Y mean. The X would be the short sleeve, the Y would be the long sleeve t-shirts. And then I'd say elimination probably is a good method to use for this one. You're going to get some big numbers because we're dealing with larger numbers on the other side, but it still works out nicely. So I'm pretty sure I have the homework written down correctly today. Substitution and elimination. The first 3, substitution. The second 3, elimination. The next 6, kind of use both. Go back and forth. Try and use substitution. I know everybody loves elimination. Volunteer for 37. Leah, 37? Thank you. Did I not get them from you? Okay, I'm sorry.